Section 2.7, prove angle pair relationships. So our goal is to use properties of special pairs of angles. Our first theorem, called 2.3, when using theorems, we're not going to use the theorem number because theorems change from book to book. We are going to use names. So this is called the right angle theorem. This says that all right angles are congruent. Our next one is the congruent supplement theorem, which states angles that are supplementary to the same angle, we'll say same or congruent angle, or if you're using congruent angles, are in fact congruent. Basically what this is saying is if you have two angles that are congruent or are supplementary to the same angle, they're congruent, or if they're supplementary to a angles that are congruent, they are also congruent. It also works for complementary angles. So angle complementary to the same or congruent angle or angles are congruent. And our last theorem is the vertical angle. So we in chapter 1 talked about vertical angles and define them. Vertical angle theorem says that vertical angles are congruent. One thing that's brought up in this section is linear pair postulate. Because if two angles form a linear pair, then they are supplementary. When you're using this one, that's what you can use. The fact that they are supplementary. You can't say they add to 180 or anything like that. You just that they are supplementary. Our first problem, we're going to change the surface L a little bit. We have given L is perpendicular to M, and you can see the box being marked, and L is perpendicular to N. We're trying to prove that angle 1 is congruent to angle 2. So like always, we are going to copy the given statement with our reason being given. Now, you have to look at what information do we have and where are we trying to go. What does it mean to be perpendicular? So we look at what is our definition of perpendicular. Our definition of perpendicular is that they intersect to form right angles. So what we can do is say that angle 1 is a right angle. And we can also say that about angle 2. The reason we know this is because they're perpendicular. For L is perpendicular to M here, we have the box drawn, so that means that angle 1 there is the right angle. We know that by the definition of perpendicular. And if you want to abbreviate perpendicular as PERT, by all means go for it. So we know that they are right angles. But what do we know about right angles? By the right angle theorem, we know that all of the right angles are congruent. Well, that's what we're trying to prove. Since angle 1 is a right angle and angle 2 is a right angle, we can say that angle 1 is congruent to angle 2. And you could write right angles theorem. If you don't know the name of the theorem, what you could write is all right angles congruent. So if you can't remember the name of a theorem or the name of a definition, you could kind of write it out. So here, all right angles are congruent. If you can't remember right angle theorem, that's fine. We'll just say all right angles are congruent. On this proof, we are given that angle 1 is complementary to angle 2. So we'll copy that down. Angle 1 complementary to angle 2. Angle 3 complementary to angle 2. Reason being given. Alright? We are asked to prove that angle 1 is congruent to angle 3. So when we look at this, what is the connection? Well, 1 and 2 together make a right angle. 2 and 3 together make a right angle. Then we look at, is there some connection between angles being complementary and congruent? And yes, if we look at the congruent complement theorem, it says angles complementary to the same angle are congruent. Well, angle 1 is complementary to angle 2. Angle 3 is complementary to angle 2. They're both complementary to angle 2, which means by the congruent complement theorem, they're congruent to each other. So we will say angle 1 is congruent to angle 3. And that is the congruent complement theorem. Or if you don't want to remember what that is, we will say angles complementary to the same angle are congruent. And that's it. This is that proof. Not all of these proofs will be long or tedious or many steps. Here's an example of a 2-step proof, which there will be a few of in this section. Our last proof, we are given that angle 2 is congruent to angle 3. We'll mark 2 and 3 are congruent. And we're asked to prove that angle 3 is congruent to angle 6. So now we are looking to make some type of a connection to get 3 and 6 congruent. There's no other information in the given that we can use, so we have to go to the diagram. Typically, when we're looking at a diagram, we're looking for something marked. There was nothing marked on this diagram. So what else can I look for on a diagram that I could possibly use? And in this case, it is, we have supplementary angles. Well, we don't have any pair here of 2 angles that form a line, so that one is out. The one we most commonly use when we have multiple sets of things going on here are vertical angles. Do we have any vertical angles? Any pairs of angles that their sides may connect? And I look at here, if I draw the sides of 2 and 6, they in fact make an M. So 2 and 6, we'll draw a double line there, are what we call vertical angles, and they're congruent. So we can say that angle 2 is congruent to angle 6, and our reason being vertical angles, or you can say vertical angles are congruent. Either way. Now we have that 3 is congruent to 2, 6 is congruent to 2. Since 3 and 6 are both congruent to the same angle, we will say they are congruent to each other. So our last step will be angle 3 is congruent to angle 6. And our reason being, 2 ways you can go on this. You can simply say I'm substituting the fact that angles 2 and 6 are congruent from line 2 and putting in angle 6 in line 1, and that's how I'm using substitution. If you wrote this as angle 2 is congruent to angle 3 and angle 6 is congruent to angle 2. Either way, you could be saying this is a chain of reasoning that I'm using and it is proper. Either one would work. I would accept either as being correct. Again, make sure that your last statement here matches what you are trying to prove. Make sure of that.